What's up, Internet? This is Josh, and welcome back to another episode of this tutorial series. Last time around, we set up our plant location so that our plants can be watered, and as they grow, they can eventually blossom into their final form, ready to be harvested. But we can't currently actually do that harvesting, so that's something that we're going to do today. There's a couple of things that we still need to do to finish that off, but there's not too much more there to do. And this is basically the last mechanic in our game. So the thing that we're going to be focusing more so on today is on the kind of like overall game structure of once we've harvested our plants, kind of understanding how that affects our scoring, understanding when our victory condition has been met, and then advancing ourselves to kind of like the next game state and kind of continuing on from there. So that's going to be a lot of what we focus on today. But we do have to be able to actually harvest plants first, so let us set that up. And there's a few things we need to do first. Thankfully, in our trigger enter 2D function here, where our player actually collides with our plant location, we already set ourselves up so that we understand that when the plant is in the harvestable state, we can just put our logic here. So much like we did the other tools, we want to just make sure that the player is holding the correct tool type before we actually proceed. So let us do that as well. And then, similar to these other functions, we don't really want to do any of the actual processing of this logic in this kind of like complex tree of conditional statements. So we're going to set ourselves up with a new function for that as well. You can just call it harvest location and put it down here. Our other harvest logic. And then, before we even do anything with that, another thing that we didn't actually do last time is in our set harvestable function here. We call it when we advance to the next seed step, but we don't actually update the state variables so that it actually, this is how the plant knows that it's harvestable when the player collides with it, as we said up here. So we need to actually set that variable when it's the plant is being advanced. Currently, this is only called from the this function here when you're advancing to the actual last step in the stage of the plants, making it harvestable. So that should be the only place that we need that. But as far as what we're actually doing when the plant is being harvested, this is where we're going to introduce a good game dev pattern that for any kind of like objects that you're expecting to reuse. So effectively, when the location is harvested, we want the player to be able to plant new plants into that location. So we basically just want to reset the location. So let's just do that. Another function that we're going to need to define, but real quick, I call it a good game dev pattern because the approach to take for this kind of thing is generally, if you are using this reset logic to kind of reset your object to be enabled to be reused for subsequent times, then it's a good idea to kind of make sure that that logic also works to be able to kind of set up your object the first time, or kind of like reset it to its, because like you're setting it to its kind of like initial usable state. So whether you're doing that when the object is first created or when you're doing that when the object is just kind of being re-enabled for the next use, it's good to make sure that this kind of like follows the same flow and that things kind of work in a cohesive manner in that way. So we call the reset from at the very start, as well as whenever we're re-enabling the object. And we can put that function up here. Now, as far as what actually happens when the reset location occurs, like I said, we want to make this location reusable for the next plant. So all of the state management and stuff like that needs to be reset. The graphics need to be reset. So let's set that stuff up. We want to set our plant to unplanted. Make sure you set it to unplanted and not to none. We want to set our current seed. Is it current seed? No. Planted seed. And this one we are setting to none. And then if we set our growing step back to 0, we established earlier in previous episodes that 0 is basically what we're treating as the empty state for the plant location. So if we check the definition for that real quick, we can see that that should pull the zeroth, the very first entry in our array here of kind of growing graphics, which is our empty graphic. And that should also reset our timer and all this kind of stuff and kind of manage that kind of stuff. And then we did see that down in, where'd it go? I was just there. In the function down here, set growing step, we set our needs water to true because that is something that is always the case when we're advancing to the next step, as long as it's not the final step. But we don't want to require water the first time we run the plant. When the plant is like, in its initial state, we can see that we have the set needs water here from before. So we just want to move this into our reset location as well, and just making sure that this is after the set growing step, because the set growing step sets it to true. So we in this particular case where we want to set it back to false. And ideally, having set up that new reset function, hopefully nothing should have actually changed in the actual functionality of our kind of like planting and kind of growing cycle here. So far, so good. Then when it gets to the final step, we can't do anything with the bucket, but if we have our scythe, we can reset, or at least it looks like the graphic goes away. Let's do a different plant. Hey, look at that. We can plant a new plant in the old location. So we have effectively set up kind of like the life cycle of our plant from kind of like initial kind of creation to kind of resetting it all the way back to the beginning, and all kind of within the same plant location. But now, like I said before, we need to actually kind of have our scoring system and update our score and kind of have a way of passing this information around and all that kind of stuff. So we're going to be doing something a little bit different here. So far, everything we've kind of set up in our game so far, all of our objects are kind of like self-managing. They all kind of do their own thing, and they kind of, there's a little bit of communication back and forth. They kind of talk about, generally they're not kind of telling each other what to do. They're just kind of saying like, hey, just so you know, this happened. And, that other object can kind of say like, oh, thanks for letting me know, and kind of do its own thing on its own side without kind of like relying on the other object to kind of like tell it what to do. So every object knows how to manage its own life kind of thing, and we're just kind of like telling it what happens, and it knows to do in those cases. But we're gonna be making our first kind of manager class in this case, where it's kind of like responsible for understanding what the different objects actually do and kind of how to put the game together in kind of like a more cohesive way, rather than just all these kind of like individual elements that work kind of like modularly, which, this is what our gameplay is, but to give our game more structure, we need something a little bit bigger than that. We're going to make ourselves a game manager, which is also going to be an object in the scene. So we'll put our script on that there. And the game manager, as the name implies, is what's kind of be responsible for kind of taking care of all the kind of like high level understanding of like when the game is won, transitioning states, and this kind of stuff like we talked about. I don't think we need this update. We will need the start. So for the game manager, we're going to use what's called a singleton pattern, where effectively we want the game manager to be accessible from everywhere. Like ultimately the game manager shouldn't be doing a lot of work for us. It's mostly just kind of passing around information and stuff like that. So it's important for everyone to be able to access the game manager and to be able, if they need it, to be able to do their jobs in some kind of way. But the game manager itself is not really doing a lot of the work itself. So basically the idea of a singleton is we're making it so that no matter what class in the game, we can just kind of say game manager dot do what I want to do, basically. Kind of like how before we set up a global class to store some of our variables in here, or some of our enums, sorry. But the difference here is our globals is just a standard script. It doesn't inherit from anything, whereas our game manager inherits from mono behavior, because our game manager has to exist within the scene in order to do its job. But in order to exist in the scene, the script needs to inherit from mono behavior. And so the singleton pattern is kind of how we get around this convention, so that any object can kind of call the game manager and access the game manager, but and then we can use the singleton pattern to actually get access to things, the objects that are in the scene, whereas the global because it isn't a model behavior, it's a lot harder to kind of like access that information and kind of get those references and stuff like that. So in order to make it a singleton, what we do is we gave it a static reference to itself, basically. And so now the idea here is anywhere I go, I can access GameManager.instance, and then from there, whatever is in here, as long as the kind of like static reference to the game manager can access that information, then any other class can kind of get at it as well. Or, you know, more likely it's going to be like function calls and stuff like that. So we need the game manager itself to make sure that the actual static instance is set, and then that's pretty much all we need to do. You know, a lot of times, generally, when you see this pattern, you know, if you ever look at other code from other tutorials or other code snippets or whatever, generally the singleton pattern, you kind of want to give it some protection so that the game manager is not destroyed if you're changing scenes and stuff like that. And you want to make sure that if you do have an instance already, that you want to like destroy that instance and set it to this one. Like the idea of a singleton is that you only ever want one game manager for your entire game, so that it persists whenever you're changing scenes and doing that any kind of stuff like that. We're not doing anything crazy like that in this game, so like we're not going to worry about that stuff too much, but just, you know, be aware that that is technically kind of like the way to kind of approach this pattern. Technically is like it's not really a singleton unless you have those kind of protections to make sure that there's a single one of them in your game. And if you're not sure what a static variable is, it's, you know, maybe a little complicated, but you can kind of think of it as it's almost like a constant in that it's a variable where you can guarantee that it's always going to be the same on every object. So if I have, you know, 3 different plant locations, they might all have different seed steps. They might all have different seed timers. But if I made a single static variable, you know, say this variable called thing, then I know that every plant location is always going to have the same value for thing. The difference between static and const is that a constant can't change, whereas a static value can. And so that's why we use it for singletons, because when the actual object in the scene, our actual game manager right here, when this object is created in the game, then it can kind of populate this actual instance variable, and that's how we're actually able to access it from other places, because no matter where you're coming from, if you're looking at the game manager class, the instance variable for any potential instances of the game manager is always going to point to the same place. In the instance of a singleton, we're probably not going to ever have more than one, like that's kind of the point of the singleton, but that's just what allows the compiler to kind of look at this variable from other places and know that it's going to be, you know, safe, or, you know, that you have some plan for it. So, you know, kind of a long explanation there, but it's not quite done yet, because we got a little bit more to go. So the next thing we're going to look at, and, you know, we'll put this all together a little bit more in a minute, but is the concept of delegates. So we've kind of used events and Unity events and stuff like that already. If we look at stuff like the plant location, this is an event call that comes from Unity, and it gives us the collision event data when the event happens. So what we want to do is set up our own events, but we're using kind of like the C# delegate system, just because it's a little bit easier to work with in code and stuff. But effectively what we're doing here is we're setting up I guess you could call it a function signature. So basically this is saying, you know, you can see that it's a void on plant harvest, and it has a parameter here. So it looks very similar to any of these other function calls that we've made for ourselves before, but it's a delegate. So effectively, the way this works, it's a little complicated, but what we want to do is, now that we've created this plant harvested delegate, we can make instances of it. We can make variables of that type. So we, you know, using the same name on plant harvested, and then I guess we can just say. Now this is effectively saying that this variable on plant harvested is kind of like a function of this type. So this is why we put the delegate in our globals class. You know, we talked before about how storing lots of values in globals is dangerous, and you don't generally want to have stuff that's like super accessible, so that, you know, anyone can look at it and manage it if they, you know, willy-nilly, even if they don't necessarily need it for any reason. But this is kind of like in these enums, the plant harvested is kind of like, it's a type. It's not really a value. So this is like a type of function that you can call. And so the way this works is on plant harvested is kind of like it's sometimes maybe called like you might call it an event listener. Basically, anyone who cares about when a plant is harvested, they're going to look at this delegate and they're going to subscribe to it, which we'll go over in a minute. And then we can later invoke the delegate. And then basically what happens is we can have this plant harvested function on any class that cares about this event. And then the invoke just kind of gives us a way to mass call all of those objects all at once and kind of like notify them of what happened. So now this is where we have this actual plant harvested function. We need to actually implement this. And then the idea is with our delegate here, we can say plus equals. And then, just like that, what we've done is our game manager has subscribed to this event. So whenever this event is called, this function will also be called. And the idea is what we could do, one of the strengths of this is you can have any number of functions that are listening to the same event. So as long as they match the same function signature with the parameters and stuff, we could say plus equals thing. And now whenever this plant harvested event is evoked, both of these functions will run at the same time. I think in this same order. And the idea is that what this does is it lets other objects in the scene kind of ask the game manager and say like, oh, like let me listen to this event and let me listen to this event, and the game manager will know when things happen, and individual objects are able to kind of like react to those events. And the idea is that like taking this approach allows us to kind of like make less assumptions about kind of what those objects are. Now to actually kind of use this whole kind of like, tangled mess of variables and stuff like that, what we need to do is in the actual plant location, when the harvesting happens, what we need to do is tell the game manager we're looking for the on plant harvested delegate. So this is this variable here. And so basically the game knows that it's looking for a function of this type of plant harvested as we defined here in the globals. And that's what this on plant harvested variable is representing. And so now knowing that it's a delegate, we can do what's called a safe invoke. And I think we just need to give it the seed type. Oh, and this actually probably needs to, because we reset the seed type, we need to call this before resetting the location. Okay, so basically, like we said before, when we call this invoke, anything that is subscribed to this delegate, as we have here with the kind of like pluses equals, this is what's going to actually call that function. So by kind of like taking this approach, the game manager will now know whenever a plant is harvested, what the type of that seed is. This is, I did this a little bit backwards because in general, it's usually individual objects are listening for events rather than the game manager listening for events. But in this case, because it's like a score management thing, it makes sense to do it this way. But give this just, we've done a lot of talking, so let's just make sure this whole structure actually works, and then we'll kind of go on from there. Water the plant. We're gonna need our scythe. Harvested pumpkin. Okay, perfect. Great. So it's great that that all worked, but let's talk a little bit about, obviously it's a little bit complicated, it's a complex way of going about things, and it's a little bit different than we did it in previous episodes. So let's talk a little bit about why and kind of what the benefits of taking this approach are. If we look at, let's start with our player controller. I guess just our plant location. This is a good one. So the main problem with the approach that we've taken up till this point is we want our code to be very modular, and we want it to be that an individual class doesn't really care about what the other classes are, what they're doing, who they are even. And so when we have this kind of approach of, if we are receiving a collision, we have to check and make sure that it's the player. We have to check and make sure that the player's tool isn't null, and we have to do a lot of kind of like making sure we have the right type and kind of so that we can assume that the interactions are going to work. And so there's kind of like a lot of overhead in that regard, and it makes it harder to kind of expand this code and start adding new things. So like if we started adding other types of enemies, maybe not enemies, but like, maybe if there's an NPC that can wander around and they had the ability to wander on top of a harvestable plant or a plant location, then we would have to set up more protections to make sure that it's not an NPC that's walking on top of this, stuff like this. So the approach that we took for making sure for actually handling the harvesting of our plants, the idea behind it is we basically don't care about the types of our objects at all. We know that the game manager has an event for when a plant is harvested. The plant location triggers that event. That's all it cares about. And soon we're going to be looking at the UI for setting this up. The plant location doesn't have to care about the UI at all. All that it has to do is tell the game manager, hey, this thing happened. And similarly, the game manager in the plant harvested here, it doesn't know what a plant location is. We don't have to care about what the plant location is. We don't care how it works. We don't care what it does. All we care is a plant was harvested. This is a long way of saying we're reducing the dependencies in our code is what we're effectively doing here. That's a lot of setup to establish a very simple communication, but it makes the game a lot easier to expand and kind of add things and change things later on. And so this is kind of like why we tend to favor this event-driven approach. However, we need to actually process the harvesting and kind of do things with it. So let's get our scoring system set up. And there's any number of ways of doing it, but I'm going to be using a dictionary. Oh, right, I need collections, generic. It's going to be dictionary of seed type and int. And the idea here is, I guess if you're not familiar with dictionaries, this is just kind of, it stores a table of all the different seed types, or whatever we add to it. But it's we can basically just store a number associated with each seed type is what this is doing. And so since we have 3 different types of scores, like what we're effectively trying to do here is we want the player to get 5 of each type of plant. So 5 pumpkins, 5 cabbage, 5 carrot. That's the other one. So this just kind of gives us an easy way of kind of storing as many kind of plant types as we need, and we can kind of keep score of each one individually. And similar to how we have this kind of reset pattern for our plant location, we want to have the same thing for our game, because ultimately, once you win, we want to move on to the next kind of game state, which I think in our case is just going to be resetting the game to kind of like initial state to 0, but kind of similar to with the plant location, since we know that that's what's going to happen, since we know the game is going to be able to start over again, then it makes sense to kind of have this reset pattern where whatever we need to do at the start is kind of similar to what we're doing when we're resetting the game. So we just need to make sure there's some values in our dictionary. Make sure it exists. And then we just need to go over all of our actual seed types, which we can just, it's a little, the actual code is a little bit esoteric, but I think it's just seed type. Yeah, okay. So this is just kind of like looking through all the values that exist in our enumerator here of seed type and kind of pushing them all into, I guess we don't want to look for none. Then in that case, we want to just go on to the next iteration of the loop. Then, depending on if the dictionary already has it, canvas is if the dictionary doesn't have it. And then, since we're resetting... Okay. You know, I know this looks a little bit elaborate, but basically it's just... And some of this we could have just done up in the start here. But effectively, we're just saying that when we reset the game, we're just... First, we want to make sure that the dictionary exists and isn't null. Then we're just kind of looking at every seed type in the game. And we want to set each seed type back to 0, effectively, is what we're doing. But so we're just... Before we actually manipulate the value, we're just making sure, okay, we don't actually care about if the seed type is none. And then we're just making sure that the key actually exists in the dictionary before we attempt to modify it or do anything like that. And if it doesn't, then we add it and we set it to 0. And in this way, we can kind of like set up the dictionary the first time we come through this code path. And then if we reset the game later on, it'll come through the same code path and it'll just say, okay, well, all these keys exist already, so we can just set the score to 0. And then down here, all we have to say is current score plus equals 1. And whatever the type of the seed is that we got passed in from the plant location, the correct row in the dictionary will get increased by 1, and that's how we increase the score of our plants. And then, you know, so this should effectively give us the ability to track our current score, and then the next thing we need to do is just pass that on to the UI. So we're going to kind of just reuse this same pattern, basically, to pass that information along, because as we talked about it, it's a good way of doing it. Effectively, what we want to do is make a new delegate. And So now our score updated event is looking for a dictionary structure, kind of like we just set up here. And all we need to do to actually like pass on the information that the score has been updated. Oh, I guess we need the actual delegate in here first. So we need a variable to store the delegate in, and then in here, where the score actually is updated, we can say invoke our... Oh, whoops, that's the wrong one. Does not exist. If I'm wrong. Oh, on score update. I should just say updated. Oh, it's called updated. So I just, yeah, okay. So yeah, now that we have this delegate, we could just have to invoke the delegate whenever we update our score. We pass along what the new score value is, and now all we need to do is anybody who cares about the score, like say maybe the UI, they just have to listen to this on score updated delegate, and then they'll get those updates automatically without having to actually interact with the game manager and the plant location or any of these other classes in any other way, other than the initial actually subscribing to the on-score updated event delegate. But that's a lot of talking, so let's not get ahead of ourselves too much. Oh, I guess I need this delegate. Actually, the parameter on this delegate needs a name. But yeah, okay. We talked about the UI and we have a plan for how we're gonna inform the UI of what's up, but we haven't actually made it yet. So real quick, let's just do that. And I guess I should start with a canvas. Basically, the way that UI works in Unity is everything is bound to a canvas, which is not necessarily the same size as your game scene or anything like that. We can see that it's actually quite large. This white box here is all our UI canvas. Here it is. Working out my mouse wheel. I gotta get a new mouse. So any UI elements that we display have to go onto this canvas here, and then so the idea is that canvas is kind of like overlaid on top of our actual game scene. So the way we're going to do this is pretty simple. We're just going to make a couple of text elements. I guess we need to import the Text Mesh Pro in essentials. And yeah, this is our text. So, cabbage score 0 out of 5. Something like that, right? So obviously we don't want it to be just kind of in the middle of the screen here. So what we're going to do is if we hold Alt and Shift, we can move it to the top right here just by clicking. And then let's see, we want to make the width nice and big. Just say 800. So obviously that's, you know, way out there. So we want to right align our text. And then what we can do, a couple of ways of doing this. You know, UI is like it's all its own thing, all together. But the easy way of doing this is to just kind of duplicate the object and then kind of move it down a little bit. And just kind of position it by eye. You know, ideally, I think the way I usually approach UI is that I would want to, I would want to put all these elements into a container and position that container somewhere so that it's like offset a little bit from the top right. But we're just kind of doing this quick and dirty. Here, we can even look in the scene to see what we're doing. So we can see that the text field is nice and wide, just to make sure that it can accommodate all the text we might potentially want to have in it. Kind of just position it a little bit. And now, you know, there's all kinds of things we could do to kind of make this nicer and whatever. But for now, we're kind of just positioning it, and a lot of the actual values and stuff like that we're going to actually be updating in code. And then give the UI its own script. Yeah, that works. We got our UI here, and let's see, what do we want to do? I guess first things first, like everything else, we want to set it up, or set ourselves up so that each kind of area of the game is responsible for its own self, right? Oh, we need the actual Text Mesh Pro reference. Let's just make sure these are in the same order. Is it pumpkin, carrot, cabbage, and then carrot? Pumpkin, text. While a lot of the code that we've been doing so far has been kind of managing the game state and the actual kind of like running of that and making sure everything is working fine, now we're kind of switching tones a little bit to the UI. And in general, you want the UI to be kind of as separate as you can from the actual like game code and stuff like that. And this is part of why we lean into the event-driven approach, because now we can just say onscore updated. We don't actually have a function for this yet, but onscore updated. And I guess we would actually need the dictionary. And just like that, because our game manager is so accessible, we can easily listen to the onscore updated event. And now our UI can get updates whenever the score changes. And no matter what happens in the rest of the game, the UI is able to manage itself without being completely oblivious to everything else happening in the game, which is effectively our goal. So again, you know, there's any number of ways you could actually go about kind of populating this data, but I guess a quick and easy way of doing it would be to just kind of do something like, if we just kind of like look at each individual kind of text string that we created in here on our UI. Let's see. Cabbage. And score. And then, you know, it's not the prettiest, but what did we decide the order? Cabbage, pumpkin, then cabbage. So basically, we can just do this for each type of plant. Carrot score, pumpkin score. And if we do the same thing here, and just set each one 0. And And this is not a good way, to be clear, this is not a good way of doing it. You don't want to be spelling out the text, in your code and stuff like that. This should all be very much a lot more programmatic. We're just kind of going through it quick and dirty at the moment just to kind of prove that it works kind of thing. And then the other thing we need to do real quick is the UI does actually need references to these text fields. I think that's it. Game Manager doesn't, at this point, need to know about the UI at all, I don't think. We have an error. C. Interesting, yeah, okay. Okay, so we're running into a bit of a annoying problem at this particular juncture, but basically what's happening is with the start on our UI runs, it's looking for the on-score update in our game manager, but the start in our game manager hasn't run yet, so instance has not been set yet. And so in order to fix that, we need to come into, I think it's project settings. We can look for a script execution order. We want to make sure that our game manager runs, we can just kind of drag it around. We want to, I think this is making sure our game manager runs before anything else effectively. Now if we run, because now that we know the game manager is running before the UI at all, we can see that our text fields are all updated to say 0 to 5. And then, to be honest, I'm not actually sure if the score will update. Let's see. Plan a couple different types of seeds here. This is one thing that we'll get into later as well. Is there are some design changes that we want to make to our game as well to just make it a little bit more fun eventually, but that's a process for down the road. So now our plants are all planted. Oh, let's see. Okay, so our scores did get updated. It looked like there was a small delay, but that might just be because we planted, or the text fields came up. Outputting text is usually very slow. It can actually slow down your system a surprising amount. But anyways, now we can see that our scores are actually updating. Sweet. Now the player actually has a way of knowing that they've progressed through the game and that they're moving towards their actual victory condition. So it's starting to actually feel like a bit like a game. But we need to actually be able to win. So we're going to do that here in the game manager. Since this is where we're kind of storing our score and processing our score, we wouldn't necessarily want to do this in the UI, even though the UI actually, we pass in a reference to what our current score is. So, maybe the UI can do some stuff here, but the actual kind of processing our victory state is something we want to do in the game manager. So we could just do this in a function, but I think we can just kind of do it right here. We'll just kind of, as we're doing our check, just make sure we can assume that from the beginning that we've won, and we can kind of try and prove that false, I guess you could say. Let's see. So we're going over all the values in our score. What do we call it? Current score? Current score. So all the values in our current score, which is a dictionary of type seed type int. Okay. Looking for them in the current score. Okay, so now for each kind of value in the dictionary, which earlier up here we populate with all the different seed types. You just check each one. And we want to win at 5, which we should probably make this a, we'll call it win target. Probably make that a constant, just so we know that it's there and we aren't relying on magic numbers. So if we haven't reached our win value, then nothing happens. We know that we haven't won, and we can break out of this for loop. But if we do get to the bottom here, and has won is still true, well, I mean, there isn't a whole lot for us to do right now, but we do conveniently have set up for ourselves already a reset game function. So in theory, this should allow us to get all the way to the end of the game, and then when we harvest our, I guess, 15th plant, if you do 5 + 5 + 5, this should reset us to a completely blank, mostly blank state. There's probably some other stuff we have to set up still, but at the moment, we're a little bit more concerned about, we want some feedback about when the win has happened. So we're gonna do something very evil. Gonna make a big screen that covers the whole display. Now we can call this our win screen. Add some text to that. And then if we go back to our UI real quick. And save a reference to that. Set that to disabled for now, and just make sure we have a reference to our win screen. And then all we need to do at this point is if we go into our UI, just make sure active, not enabled. Thinking about Godot, I think. Too many game engines. We just want to make sure that this is set to false by start because we don't want to see the win screen until we win. And then we need an actual way for the UI to detect when the game is being won, so they can turn on that screen that we just made. So I talked a little bit a minute ago about how we do get the score value in the UI here, so we could just use this new score value and do the check here and call the game from here. But a better approach would be is if we make a new delegate, because it's pretty reasonable to expect that other parts of the game will also care about when the game is won, so that they can potentially also reset. Then we can just kind of make one delegate and make sure everyone is kind of listening to the same thing, and all the processes are kind of like originating from the same place. You can see that all these events that we've made, they all start with the term on, which is just kind of a good naming convention that kind of declares that this is something that happens on an event when an event actually happens. So we could say on game win, invoke. I mentioned this earlier, I guess I didn't really go over it, but this little question mark dot invoke thing, I think it's just called a safe invoke. And basically what it does is it just makes sure that as long as there's a value in here, it will invoke it, but if there is no value, then it won't. So it's just a really quick and easy way to kind of like write that code in a safe way without adding all kinds of like checks and craziness. So, okay, now we have it so that when the game is actually won, this on-game win event should be invoked, and so we just need a way for the UI to listen to that as well. So now, whenever this game win is evoked, it should turn on our win screen. So let's see. Seems like our score is not actually being updated, or at least the UI isn't being updated anymore. Let's see what's happening. Oh, yeah, okay. I guess, yeah, it was about time this came back to bite me, I guess. I didn't actually, this is not using the actual correct types. It's not like looking for the right, the UI is not looking for the right plant types when it's updating the score. So they were all looking for cabbages. So if the player never planted any cabbages, or basically all three text fields were always displaying the player's current score for how many cabbages they've harvested. Let's try that again. There we go. Of course, you know, you can... That was a mistake. You can also, you know, change these values so and do stuff so that it's not quite so painful for you to test. But, you know, we're here. We're not going to worry about it at the moment. Fast forward. Hey, we did it. Okay, that was an annoyingly long amount of time to to test. And our game doesn't actually, you know, maybe it actually does reset. Let's see what it does in the background. We turn off this windscreen. What's happened? I guess nothing. You know, we can, notably, our player can still move around and all that kind of stuff. Our score actually did reset. Okay, the UI just didn't reset, but our score did reset. You can see that it's gone back down to 0. So, you know, there's more for us to do here to actually properly reset the game so that it can restart from the beginning. But now we finally have a fully complete game loop from all the way from, you know, planting the seeds to harvesting them to getting score to eventually, you know, it's an arbitrary condition, but winning the game, so to speak. So there is still more for us to do here. We've got a whole bunch of polish to do. You know, our UI code is really gross, and there's a lot more we can do to make the game more fun. And we're going to try and focus a little bit more now on kind of like, you know, they say make it exist and then make it good, right? So we're going to start, we're going to spend a little bit of time trying to make it actually good. Just find some easy small places to just kind of like up the quality a little bit, make it a little bit more engaging, make it a little bit more fun, make it communicate to the player a little bit better. And all these kind of things. Because, you know, obviously that's an important part of the game development process as well, and that's what we're focusing on here. So, you know, it's not just about making the game, you've got to make it fun too. But this episode is long enough, so we'll talk more about that on the next one. If you've enjoyed this tutorial, then feel free to like, comment, subscribe, all those things that YouTube people do. And I will catch you in the next one. See you later.